Hi, this is Juan from JuanTutors.com. Welcome to my totally free office hours. Today we are working on the August 2016 New York Algebra 1 Common Core Regents Problem 3. If you want to access these exams, whether you're from New York or from anywhere else in the world, you do not have to be a resident of New York. Just go to nysedregents.org, click on the appropriate tab, and all the past regents are freely available there. Here's the problem. Which statistic cannot be determined from a box plot representing the scores on a math test in Mrs. DeRitter's algebra class? The lowest score, the median score, the highest score, or the score that occurs most frequently. So before we do this, we hopefully should know what a box plot looks like. It looks something like this with a box in between, okay, and something like that. Hopefully we know what all these things represent, okay. But it's a very simplified version of the graph. From this we can't see even how many people there are in the graph. So we can see the lowest score on the number line. So on the number line, this is where the lowest score is located, okay, lowest score, and this is where the median is located, okay, and this is where the highest score is located. In this graph, we don't show our outliers. This is where Q1 is located, Q1, and this is where Q3 is located. Let me put Q1 in capital since we always see it as a capital letter. Okay, so the lowest score can be seen, which makes this wrong. The median score is that line, so that is true. So that's not it. The highest score is again there, excuse me, and then Q1 and Q3 excuse me, Q1 and Q3 are also the other scores that are visible directly from this graph. So this has to be then the answer, the thing that cannot be seen, the score that occurs most frequently. And again, we only see 5 scores: the lowest, Q1, the first quartile, the median, the third quartile, Q3, and the highest score. Those are the only things that we are seeing. And we can see behavior too, the skewing of the data. Like this data is skewed to the left, and it's more spread out at the right. So this is skewed left. We could see that. We could calculate the interquartile range, and we can calculate the range by subtracting the lowest and the highest, and the interquartile range by subtracting Q3 minus Q1. But we can't see how many of each data point appears. So here's a similar practice problem created by us. At this point, you should pause the video, try the problem on your own, and when you're finished, press play to see our solution. By the way, we're able to provide these tutorials totally free because of viewers like you seeing the videos. So if you like what you see, click the like button, subscribe, and let your friends know that these videos are available. We are providing tutorials in algebra, geometry, algebra 2, trigonometry, biochem, physics, and more to come, so look out for those. Here's the problem. Which statement is always correct about a box plot representing one 10-meter hurdle race result at the Olympic trials? Choice 1, we can determine whether the mean is greater than the median. We can determine the number of 110-meter hurdle participants. We can determine whether the median is greater than the mode, or we can determine whether the interquartile range is less than half the range. So there's some of these that, based on the box plot, knowing what the box plot looks like, that we should be able to eliminate. Again, a box plot might look like this. Maybe this one's skewed to the right. That's the full graph, independent of how much data there is. That's what the graph. So we might be able to eliminate some of these without knowing how to do it. But let's see, we can determine whether the mean is greater than the median. Maybe. Let's think about that for a moment. We can determine the number of 110 hurdle participants. Here are no quantities at all, so that has to be wrong. We can determine whether the median is greater than the mode. Again, the mode is the data point that occurs most often. Mode, most. So this can't be it. And we can determine whether the interquartile range is less than half the range. Okay, so let's see. Minimum. Here's Q1. Here's the median. Here's Q3, and here's the max. Okay, so let's see, determine whether the mean is greater than the median. Here's the thing about the mean. We don't know how many data points are, how exactly the data is spread. We know it's skewed to the right, so we know the mean and the median are both going to be, bigger than whatever the midpoint is, but they're both bigger. Beyond that, we don't know which is the biggest. So there's no way for us to know if the mean is greater than the median, so it has to be this. And so let's see, we can determine whether the interquartile range is less than half the range. Well, the interquartile range is a calculable number. It's Q3 minus Q1. It's a calculable number. So here's let's put this capitalized, but we know what it is, Q1. We can calculate it if we know the numbers, and then the range is equal to max minus min. So we can definitely determine if this number is less than half of this by comparing them. Is IQR over the range, is this less than 1/2? I don't know, but if we have those numbers, we can calculate them. So it has to be choice 4. Okay, thanks for watching. Stay tuned for the next video starting right now.